Good day, I'm Dr. T and welcome to my office. So today I'd like to talk a bit about trends on the periodic table. So if you look at a periodic table, we can look at general regions of the table and get a feel for what elements are going to be sort of like, because there's some fairly overarching trend. There are typically going to be a diagonal trend running from the lower left-hand corner near francium up to the upper right-hand corner near helium. The first trend I'd like to talk about is metals, nonmetals, and metalloids. Roughly the left two-thirds of the periodic table are what we refer to as metals. Now, to be clear, this is a continuum, and metallic character follows that same diagonal trend I referred to earlier, with heading towards francium to the lower left, becoming more metallic character, and heading towards helium in the upper right, less metallic character. So what is this metallic character? So metals are going to be compounds that typically like to share their electrons with each other, forming electron seas. This gives them some rather interesting properties. Typically they're going to be shiny, they're going to be good conductors of heat and electricity, and they can be beaten into sheets, what's called malleable, and stretched into the wires, what is known as ductile. Low metallic character has the opposite properties. So nonmetals, which if you look at a periodic table and draw a diagonal line going from beryllium down towards radon, that is kind of the cutoff between what we typically refer to as metals and nonmetals, with nonmetals being in the upper right of that diagonal line. Nonmetals are going to have very much the opposite properties. Typically, they're fairly decent insulators, although carbon can be an exception when it's in the form of graphite. Additionally, these are not going to form large electron seas. They typically form small clumps of atoms, which we refer to as molecules. Because of this, when they're in their elemental form, they typically, if they are not a gas, they will form fairly brittle solids that are typically fairly dull. And they will not be malleable or ductile. Instead, they simply turn into powder. Now, those elements on that diagonal line running from beryllium down towards francium that I referred to earlier are usually referred to as metalloid. These have sufficient metallic character that they're not properly described as nonmetals, but they don't have enough to really be described as metals, and thus they are kind of an in-between position and have properties of both. This has actually proved to be incredibly useful to us for the use of things like semiconductors. You'll note that silicon is a metalloid. A few other trends that run from the same diagonal francium to helium trend. Atomic size goes up as you get closer to francium. Effectively, what's happening is as you go down the periodic table, increasing your period number as you go towards the bottom, you're adding extra layers of electrons, and thus, it's like an onion with more layers on it. It's going to get bigger. As you go from left to right, the ratio of charge in the nucleus relative to the number of valence electrons goes up, and it's able to pull the electrons in slightly closer, and therefore those elements shrink in size. Therefore leading to a trend where down towards francium you have the largest atoms, and up towards helium you have the smallest atoms. Additionally, with these trends, and effectively because of those two effects, once you're down towards francium, because there is a greater distance between the nucleus and the valence shell, and because there's a lower ratio of protons to valence shell electrons, it's fairly easy to remove electrons from the valence shell in that direction. Therefore, we say that these have a low first ionization energy. They're low because it doesn't take that much energy. First ionization means it's the first electron to be removed. It always takes more energy to take the second and third and fourth electron off. It always increases, although the rate of increase does vary depending on where in the periodic table you are. But for that first electron, it's easiest to remove it if it is down towards francium, hardest to remove it if it is up towards helium. Also, the inverse of this is the willingness for the atom to either acquire an electron or to share it in an unequal way, that it hogs the electrons. This is what we call electronegativity, and as would be expected, this follows the opposite trend to first ionization energy, with up towards fluorine and helium having high electronegativities, and down towards francium having very low electronegativities. Essentially, this is the opposite concept, where first ionization energy is how easy it is to lose an electron, whereas electronegativity is how likely is it to try and obtain an electron, either a downright steal or at least an uneven sharing. So with that said, those are kind of the major trends within the periodic table, and have a wonderful day.